Good morning, students. Now the last problem is find the recurrence. Find a unique solution of the recurrence relation 6an minus 7an minus 1 is equal to 0, where n greater than or equal to 1, a3 is equal to 343. Right? This continuation. See, find a12 if if an plus 1 square is equal to 5an square, where an greater than 0 for n greater than or equal to 0 and a naught is equal to 2. Right? This is a recurrence relation, but it is not a linear recurrence relation. Right, the given recurrence relation is not a linear recurrence relation because the product of terms are there. An into an is an square, an plus 1 into an plus 1 is an plus 1 square. If the product of terms present, then that equation is not linear. Right, now we have to find a solution of this given recurrence relation. Now given that an plus 1 square is equal to 5an square, where an greater than 0 for n greater than or equal to 0. Now first of all, we are converting the given given recurrence relation to linear recurrence relation. That means we are assuming let bn is equal to an square. Bn is equal to an square means bn plus 1 is equal to a suffix n plus 1 whole square. Now b naught is equal to what? B naught is equal to a naught square or a suffix 0 square. Bn is equal to an square. Now put n is equal to 0, you will get b naught. N is equal to 0 means a naught square. But a naught is equal to 2 here. 2 whole square means 4. Therefore b naught value is equal to 4. Right? Since a naught value is equal to 2, that's why b naught is equal to a naught square means b naught value is equal to 4. Now here the given equation, the given recurrence relation can be written as bn plus 1 is equal to 5 into bn. See, an plus 1 is bn plus 1, right? An plus 1 square is bn plus 1. 5 into an square can be written as bn. Now bn plus 1 is equal to 5 into bn, right? Where n greater than or equal to 0, b naught is equal to 4. This is a linear homogeneous recurrence relation. Now the solution of this recurrence relation is bn is equal to capital A into d power n, where a is equal to the initial value, that is nothing but b naught, and d is equal to the coefficient of bn, that is 5. Therefore the solution is bn is equal to 4 into 5 to the power of n. An square is equal to 4 into 5 power n. What is bn here? Bn is an square. No, that's why I wrote an square is equal to 4 into 5 power n, where an is equal to square root of 4 into 5 power n. Square root of 4 is 2. Right? Square root of 5 power n. Therefore the solution of given recurrence relation is an is equal to 2 into square root of 5n whole to the power of n. Right? Now here we have what you have to find again. You have to find a12. A12 means, right, put n is equal to 12 here. Therefore 2 into square root of 5 power 12. Under square root 5 power 12 means 5 power 6, right? Now 2 into 5 power 6. If you multiply this one, here a12 is equal to 31,250. 5 power 6 is equal to 5 into 5 into 5 6 times, right? 2 5s are 10. Next 5 5s are 25. 25 25s are 625. 625 into 5 is equal to 3,125 into 10 is equal to 31,250. Next, find a recurrence relation with initial condition that uniquely determines each of the following sequence that begins with the given terms. Number 1, 3, 7, 11, 15, 19 and so on. Second one is 8 to 24 by 7, 72 by 49, 216 by 343 and so on. Here given sequence is equal to, first of all we are writing 3, 7, 11, 15, 19 and so on. The first term is nothing but a naught is equal to 3. Second term is denoted by a1 is equal to 7. third term is denoted by A2 is equal to 11. Now the common difference, this is in GAAP actually, right? Second term minus first term, 7 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4, right? Now therefore the common difference is 4, right? Therefore the sequence is increases by 4. That means what is the relation between the first term and second term? First term is second term is equal to first term plus 4, no? Right. Now therefore an plus 1th term is equal to nth term plus 4, or you can write nth term is equal to its preceding term, sorry, previous term, and an minus 1 plus 4, preceding term plus 4. Now this is the recurrence relation. Here an is equal to an minus 1 plus 4, where n greater than or equal to 1, a naught is equal to 3. The second one, given sequence 8 comma 24 by 7 comma 72 by 49 comma 216 by 343 and so on. The first term is a naught is equal to 8. Second term a1 is equal to 24 by 7. This is 8 into 3 by 7. Third term is 72 by 49. That means 24 by 7 into 3 by 7. Right? 24 by 7 into 3 by 7. The 24 3s are 72, 7 7s are 49. That means the given sequence, in the given sequence, each term, the next term, next term, that means the previous term is multiplied by 3 by 7, then you will get the next term. That means each term get multiplied by 3 by 7. Therefore an is equal to 3 by 7 into a suffix n minus 1, n greater than or equal to 1, where a naught is equal to first term is 8. Now if you put n is equal to 1, you will get a1 is equal to 3 by 7 into a1 minus 1 into a naught is 8, 3 by 7 into 8, that is 24 by 7. If we put n is equal to 2, a2 is equal to 3 by 7 into a suffix 2 minus 1, that is a1. What is a1 value? 24 by 7 into 3 by 7 is 72 by 49, right? Next one, a person in a person, this is person, a person invests rupees 1 lakh at 12% interest compounded annually. Find the amount at the end of first year, second year, third year. Write the general explicit formula, or you can write recurrence relation. Third one, how long will it take to double the investment? Now the given investment, the investment is 1 lakh, right? The amount is 1 lakh, rate of interest is 12. Let an represents the amount at the end of n years. An represents the amount at the end of n years, right? An is equal to a suffix n minus 1 plus 0.112 into a suffix n minus 1. That means the capital amount plus in its interest. If you add the interest, then you will get the amount after 1 year. Here an minus 1 common, 1 plus 0.12 into an, that is an is equal to 1.12 into an minus 1 for n greater than 1. Here a naught, the initial amount is equal to 1 lakh. After 1 year, you will get interest now. What is the rate of interest now? 1.12, right? Now a1 is equal to 1.12 into a naught. Right? If you use this, you can use this formula. An is equal to 1.12 into an minus 1. A1 is equal to 1,12,000. This is the amount we will get at the end of first year. Similarly, A2 is equal to 1.12 into A1. A2 is equal to 1.12 into A1 value is 1,12,000. If you multiply, we will get 1,25,440. This is the amount we will receive after the second year. Right? Similarly, A3. A3 is equal to 1.12 into A2. If you substitute A2 value, you will get 1,40,492.8. Right? Now, the amount at the end of first year is 1,12,000. The amount at the end of second year is 1,25,440. The amount at the end of third year is 1,40,492.8. Now, we know the relation A1 is equal to 1.12 into A0, A2 is equal to 1.12 into A1, A3 is equal to 1.12 into A2, and so on. AN is equal to 1.12 into AN minus 1. Now, if you want to write the recursive formula, this can be written as in terms of A0 we are expressing. That means AN is equal to, suppose if you want to express, listen carefully. Now we want to express A3 in terms of A1. In terms of A1 means, say A3 we know A3 is equal to 1.12 into A2. No, what is A2 value? A2 value is 1.12 into A1, right? That means A3 is equal to 1.12 into 1.12 into A1. If you want to express A3 in terms of A0, that means again A3 is equal to 1.12 into 1.12 into what is A1 value? A1 value is this one, 1.12 into A0. Therefore, A3 value is equal to 1.12 into 1.12 into 1.12 into A0. Similarly, if you want to express AN in terms of A0 by back substitution, you will get 1.12 into 1.12 into so on n times 1.12 into A0. That means AN is equal to 1.12 whole power n into A0. This is a recurrence relation. AN is equal to 1.12 whole power n into A0. And the C bit is amount will get doubled, right? Now, after n years, let A0 initial amount is equal to 1 lakh. Now, assume that AN is equal to 2 lakhs. After n years, the amount will be doubled. Now, we have to find the value of n. Similarly, here AN is equal to 1.12 whole power n into A0. No? Now, AN value is 2 lakhs. 1.12 into n into A0. What is A0? 1 lakh. If you substitute in that formula, you will get n is equal to log 2 by log 1.12, that is equal to 6.12 years. After 6.12 years, the amount will get doubled. After 6.12 years, the amount will be doubled, right? Now, sir, idella vachindi sir after simplification. Now here 2 lakhs is equal to 1.12 whole power n into 1 lakh. No, now these zeros gets cancelled. Here 2 is equal to 1.12 whole power n. No, right? Here formula is, suppose log x base y is equal to n implies y power n is equal to x. Y power n is equal to x. Similarly, now here this 1.12 power n is equal to 2 means what you will get? Log 2 to the base 1.12 is equal to n. See, here you apply this formula. Here this is in the form of 1.12 whole power n is equal to 2. This implies what you will get? Log 2 to the base 1.12 is equal to n, right? But log 2 to the base can be written as log 2 by log 1.12. Log 2 to the base 1.12 can be written as log 2 by log 1.12. By using logarithms, you will get the value. That value is nothing but 6.12 years, right? Now, these are the practice problems. Try cheyandi. Try chesi naku ping cheyandi. 1 2 3 4 5 6 7 problems are there. Try to solve these problems.